A histogram is a visual representation of a frequency distribution table. Notice here that we have a frequency distribution table that represents the heights in meters, ranging from 1.34 all the way up to 1.69 meters, and a frequency column ranging from 4 to 31 individuals that fall within those different classes. When you create your histogram, you want to make sure that you have some sort of straight edge tool, such as a ruler, so that way you can make equally spaced tick marks. When you're creating your horizontal axis, this will always represent your classes, in this case, heights in meters. Your vertical axis will always be the frequency for those classes. It is not necessary for your tick marks to be the same size. For the heights of my frequency, the lower part is going to start at 0, and I'm going to create each of my tick marks to be an increment of 5. To make it easier to read, I'm only going to label every other tick mark. Remember that your classes are just values along a number line, so my horizontal axis is also just a number line. When we are creating our histogram, we are showing the number of frequencies or the number of data values that fall within that section of my number line. When creating a histogram, we want to use a bar to represent the number of data values that fall within a certain section of that number line or class. For the first class, 1.34 to 1.39, we have 4 values that fall within that class. I'm going to have to approximate 4 because I don't have tick marks that go 1, 2, 3, 4. So I'm going to put my bar where it looks like it goes pretty much close to 4. When you see the value labeled at the bottom, 1.34 to 1.39, that represents your heights in meters, that is a chunk of the number line. We're going to write the class width like that so that way we don't have to actually write all of those values along the number line. So that bar height represents the class. If I then want to show the data values or represent this in a picture for the second class, where there are 14 data values that fall within that class, again, I can see where I have my height of 15 on my frequency chart, so I can put 14 about where it looks like it might fall. So for the class representing 1.40 to 1.45 height of meters, 14 data values fell within that class. We can move our horizontal label to the edge so that we can continue to write our classes along the bottom, and continue our bar heights for the rest of our frequency distribution table to see a value or a picture of what this is going to look like. Notice that I have a nice clear picture of how the frequency distribution table translates into this histogram, so I can see the spread of the data a lot easier. Notice this data falls in what we call a normal distribution because the height is roughly in the middle and falls down in a symmetrical or bell-shaped pattern. While it is not necessary for you to write the labels of the frequency at the height of each bar, it's often very helpful, especially when you don't have the original data or the frequency distribution table to easily see what's happening in each of those individual classes.